Welcome to the solutions of assignment 6. In this video we are going to talk about exercise 6.3 on the concept of the critical sales loss. In this exercise we are faced with the following situation. We are asked to consider a company that manufactures and sells t-shirts over the internet. We know that this company sells a quantity of 1,000 t-shirts at a price of 10. And we furthermore know that the average costs, the very average cost of this firm at this point is lower C equals 6. All right? So that's the situation we are starting from. And before we are actually calculating the critical sales loss and the critical price elasticity and so on, let's first talk about these concepts in general terms. So we are first asked to verbally explain the concept of the critical sales loss and the critical price elasticity. Let's start with the concept of the critical in brackets sales loss. So the critical sales loss answers the following question. What is the maximum amount of sales that can be lost in response to a price increase, so that the price increase does not become unprofitable? So let's step back for a minute and think about what this means. Let's start at the very beginning. We know that there is a demand function for which the quantity demanded decreases in prices. That's our starting point. And if we have this nicely behaving demand function, well, that of course implies for any increase in price, we will have a lower demanded quantity, okay? And now the critical loss makes use of this property of the demand function. Namely, it's asking, well, of course demand is going to decrease when we are increasing the price. But now on the profits, we have two opposite effects. We have a larger margin due to increased prices, so we are earning more on each individually sold product. At the same time, we have the problem that we are selling a lower quantity, right? And of course, we are losing the entire margin on every unit that we are not selling anymore, okay? And now the critical sales loss is asking the question, the sales loss analysis, I should say, is asking the question, now, what part of these two counteracting effects is overweighing the other, okay? So, we are asking, what is the maximum quantity Q that we can lose in response to an increase in price? So that we still make at least the same profits, ideally, of course, larger profits. So how much Q can we lose in response to an increase in margin, driven by an increase in price, of course. And in the following we will talk about price increases that are in the region of 5 to 10%. We will have a look at one example where we are analyzing 15%. And now, if we want to assess whether or not a price increase is profitable, we of course have to compare the actual loss of a price increase. So how much does quantity decrease actually for a given price increase, with the critical sales loss. So how much quantity can we lose so that the increase is still not unprofitable. Okay, and that's exactly what we're going to do. Of course, the interpretation at this point should be relatively trivial, right? As long as the actual loss is larger than the critical loss. And again, the critical loss being the maximum amount we can afford to lose without being unprofitable. If the actual loss is larger than the critical loss, then of course the price increase is unprofitable. And if the actual loss is smaller than the critical loss, then the price increase is profitable. All right. Of course, and I should add this because these of course are two separate videos. Sometimes that's easy to forget. We are talking about the critical sales loss analysis in the context of market definition. Okay, so we can use this price increase on all products that we are analyzing in a given market definition. So we start by some market definition, and now we think about what happens if we have a price increase. And what is the actual loss from this price increase, all right? And as long as the actual loss of any price increase is smaller than the critical loss, so the maximum affordable loss, so to speak, we have found, as long as the actual loss is smaller than the critical loss, we have found the relevant market because a price increase is profitable. This concept is very closely related. I would even say it's the same concept as the snip test, which we were discussing in the previous exercise, right? Because we are again considering a situation where we have a price increase and are asking ourselves, is this price increase profitable? And as long as the actual loss is smaller than the critical loss, a price increase is profitable, so we have found the relevant market. If a price increase is not yet profitable, well, then we have to extend the definition of our market to include more products until we reach this situation where the actual loss is smaller than the critical loss. Okay, so we can use this whole concept of the critical sales loss or critical loss analysis in order to find and define markets, the relevant markets. Okay, of course, in this exercise, we are not considering more and more products. We are not broadening the market definition or anything. We are not using this tool for market definition in this exercise, but rather we are just toying around with it and analyzing the actual profitability of these price increases. So this is just for context, because we are using or we are analyzing and we're discussing this exercise in the context of market definitions. All right, so that's the concept of the critical sales loss. Now to the concept of the critical price elasticity, eta with a lower c as an index for critical. This is conceptually the exact same thought experiment, only difference being that we are no longer looking at quantities reducing and prices increasing, but rather we are looking at elasticities. So, of course, elasticity is nothing but a relative quantity change for any given relative price change. So the elasticity, the price elasticity eta, is already putting these two sizes, these two entities into a relation. So we can make, of course, use of this. We are interested in the relative change of quantity for relative change in prices. So let's make use of the elasticity because it's providing exactly this concept for us. Okay, so we can, of course, have the same analysis, conceptually the same analysis, but use the price elasticity eta for this. And the idea just the idea of this critical loss analysis just applied to the critical price elasticity concept is, of course, is of course as it is written in this quote. So it's maybe easier to just read it straight up from the slide. What is the maximum actual price elasticity eta such that the current price P with an index 0, P0, the current price, raised by T, so this is the price increase T, is below the monopoly price PM. So monopolist price with an index M. This is the case for the critical price elasticity, all right? So we are looking for the maximum price elasticity eta such that the price increase is below the monopolist's price. Very similar to what we did on the previous slide. And then in the next step, similar to what we just did and discussed with the actual price loss and the critical price loss, actual sales loss and the critical sales loss, we are of course comparing the actual elasticity with the critical elasticity. And if we observe an actual price elasticity that is larger than the critical price elasticity, then we see a rather high demand substitutability, and we see that the monopolist price exceeds the benchmark price P0 by less than the price increase. Okay, so we have not yet found the relevant market simply because the demand substitutability within the goods we are currently observing is not large enough. The opposite, of course, happens as soon as the actual demand elasticity is smaller or equal than the critical demand elasticity. So we have a rather low demand substitutability. And in this case, that means that the increase, the price change P0 multiplied with T, or in terms of if T captures a relative price increase. So the new price P0 increased by T is now smaller than the monopolist price. Or in other words, as it is written on the slide, if the monopolist price PM exceeds P0 by more than T. All right, in this case, the relevant market is found. So again, the same concept we just talked about when we were talking about the critical sales loss analysis. But in this time, already considering this relative connection between price changes and quantity changes, which we have in the price elasticity. All right. Now we have talked about the concepts of the critical loss analysis and the critical price elasticity. Let's next continue with a few actual calculations, just to follow along with this example. We are now asked to show that the absolute critical sales loss, so we are talking about absolute quantities, not relative quantities, for a 5, 10 and 15% increase is, and then we already are given the results we are asked to check. So is 111 t-shirts in the case of a 5% price increase, 200 t-shirts in case of a 10% increase, and then finally 273 t-shirts in case we have a 15% price increase. And this, of course, now the only question is, how do we calculate this? And because it's of course the exact same calculation for each of these three scenarios, just with different numbers plugged in, let's do this once for a price increase of 10%. Okay? So, if we want to answer the question whether or not this price increase is profitable or not, we need to compare the situation before the price increase with the situation after the price increase. Okay? So let's start by calculating the situation before the price increase, or the starting point. In the benchmark situation, in the starting point situation that was outlined in the exercise description, we knew that the gross margin, so price minus costs, is 4. So we are earning a gross margin of 4 for each t-shirt sold. And we also know that the company sells a quantity of 1,000 t-shirts in this benchmark situation. So the total revenue in this situation is rather easy to calculate. The total revenues are rather easy to calculate because it's price margin times the quantity sold. So in this benchmark situation, the firm is earning 4,000. All right. Now let's analyze a situation where the price increases by 10%. And we don't use this by accident in our example, but of course a price increase by 10% for a given starting point of a price of 10 yields a price of 11. So in this now comparison situation, we have a price of 11. This increase of the price by 1, of course, for unchanged costs of production, yields a gross margin of 5. All right. So what we can then calculate is, what we then can calculate is, well, how many t-shirts would we need to sell in order to match the profits in the benchmark situation? So the profits in the benchmark situation, 4,000, we are now earning a gross margin of 5 for each t-shirt, so we would need to sell at least 800 t-shirts after this price increase. For this, if we sell at least 800 t-shirts in this comparison situation, well, then we have at least equal profits, right? So we have now found the critical sales loss. So the quantity of the good which we may at most sell less. Okay? In the benchmark situation, we sold 1,000 t-shirts. After the price increase, the firm would need to sell at least 800 t-shirts in order to match the profits of the benchmark situation, which of course implies that the critical loss, so the most quantity, the maximum quantity the firm can lose in sales is 200, the difference between these two sales numbers. All right, so just one last time to reiterate what we now know about the market and about the firm. Well, we know that if the firm, after this price increase, sells less than 200 fewer t-shirts, then in this case the price increase would be profitable. And of course the other side of the coin then implies that if the loss in sales quantity that comes with this price increase is larger than 200, well, then the price increase is no longer profitable. So this is the critical sales loss, 200. All right, we can do, of course, exactly the same for 5 and for 15%. We simply have to calculate what is the new price in case of a 5% price increase. And then for the new price, we know the new gross margin. And for this new gross margin, we can calculate how many t-shirts the firm would have to sell in order to match the initial benchmark situation's profits of 4,000. Okay? And from this difference, we then can calculate what the critical sales loss in t-shirts would be for the firm for any of these given price increases. The solutions of these calculations are given on this slide. For 10%, of course, we already calculated, it was 200, so this is already confirmed. Then for a 5% price increase, if we run the same calculations, we will see that the quantity is 111, and for a 15% increase, we will then see that the critical sales loss is 273. And then just to sum up this whole exercise, the interpretation of each of these combinations of price increase and quantity respectively would be that in the example of the 10% price increase, a 10% increase in price would not be profitable for the firm if the reduction in sold quantity is larger than 200 t-shirts, and analogously for 5 and 10% increases. Just, switching out the numbers, of course. All right. Now, in the next exercise, we are asked to discuss what data should be available or needs to be available if we want to define the relevant market in this case. That, of course, depends on whether or not we want to talk about the critical sales loss or the critical sales, the critical demand elasticity. Both of these concepts are similar, but of course, if we want to calculate the elasticity, we need to know a little more than just one single price and quantity combination, because we would have to infer a demand function. All right, so to sum up, in case we want to estimate the price elasticity of the demand, we would need prices and quantities, and furthermore some product characteristics, simply so we can model this substitution between these products. Prices and quantities in this particular case, of course, refers to multiple combinations of prices and quantities. Why is that the case? Because, well, if we want to estimate elasticity, so relative changes, or expressed, or alternatively expressed in the non-discrete case as derivatives of the demand function, of course, we need to estimate a demand function first. And of course, in the real world, demand functions typically do not behave as nicely as they do in this lecture. So we usually do not see linear functions. So we need a bunch of combinations of price and quantity so we can actually estimate a demand function, and with that, the price elasticity of this demand function. For the case of the critical sales loss, well, that's of course a little bit easier because we are thinking in a discrete world, so we don't need to estimate the demand function. But still, as you have seen in the previous exercise, we need to know some combinations of price increases and the quantities sold for each of this increase. So we do not need to know the precise demand function, but we need to know at least 2 points on the demand function, of course, because these 2 points will then be used as in a comparison to see if the actual loss is smaller or larger than the critical loss. Okay, so we still need price and quantity combination, but in this case, strictly speaking, 2 points would suffice in order to make a statement, at least when it comes to this specific price change that defines these 2 points. But ideally we would of course need, again, some kind of natural experiment, so some kind of exogenous shock that changes the price at some point, or at some point. And of course we need to observe the sold quantities before and after this experiment. Why are we talking about natural experiments again in this context? Well, simply because we cannot, we need to rule out that there's a strategic decision of the firm behind this price change. For example, a change in expected demand, or for example, a change in quality or anything like this. Because in order to make a statement on the critical sales loss, we need to ensure that the demand function that is behind this whole experiment is the very same for both observed prices and quantities in combination. All right, so we need this exogenous shock, or in other terms, this natural experiments that provides for us with 2 combinations of prices and quantities that were market equilibria at some point.